Hello, my name is Olga Gadyatskaya, and today I'm glad to present you our paper Dissecting Android Cryptocurrency Miners. Cryptocurrency mining consists in winning a competition with other miners by solving computationally hard problems. This is also called proof of work. So basically, miners compete with each other, and whoever first solves this computationally hard puzzle will receive a reward as minted crypto coins. And today there are many cryptocurrencies. Most popular of them is probably Bitcoin, and also many software and hardware stacks for mining. When the cryptocurrencies have been on the rise, especially during 2017, mining has emerged as a new monetization strategy that allows users to trade in computing time and energy for rewards in this cryptocurrency. And for instance, Pirate Bay has experimented with replacing ads with crypto mining in the browser, but it didn't work out. Cryptojacking is when cryptocurrency mining is embedded as a payload in malware and runs on hacked HPC systems. For instance, recently in European universities, systems have been hacked and crypto mining has been deployed. Also, end users, PCs, and even smartphones can be vulnerable to cryptojacking. Indeed, cryptocurrencies can be mined even on smartphones, and during this boom in cryptocurrency markets, third-party mining applications have been developed, and they have become more and more popular on both Android and iOS mobile platforms. However, Apple and Google moved to outlaw crypto mining applications in 2018 because they are actually dangerous to devices. And for end users, it's even not profitable to mine on their own smartphones, so they will not receive substantial rewards to cover their energy expenses. And even unscrupulous mining can damage the device by overheating and damaging the battery. But for attackers, we can say that cryptojacking is almost free, and it is actually very easy to integrate mining in applications by using dedicated software libraries, and also mining services like CoinHive that has been very popular. They facilitate pooling, so whereby an individual device can join a pool with other devices and mine together with them. So when the cryptocurrency is mined, then the rewards will be shared for all participants of the pool. Here I have a screenshot of ARM miner, and this was a popular mining app on Android, where the end user can configure mining configuration and run mining on their own device. So in our study, we wanted to investigate what is actually this phenomenon of crypto mining, specifically on Android. And in our paper that you can check out at the CODASPY proceedings, we report about how crypto mining can actually be implemented in Android apps. We describe our process that we have established for collecting crypto mining applications. We analyze the data set of apps that we collected, and we report some characteristics of crypto mining applications. And we also propose an approach to dynamically detect crypto mining and cryptojacking when they mine on device. We responsibly share our data set. If you're interested, please get in touch with us. On the last slide, I will have contact details. So just to describe to you how crypto mining can be done on Android. Android applications are written in Java and Kotlin, but they can also include web code and binary code. And these two are the most popular two ways how crypto mining can be implemented in Android. So the third-party crypto mining libraries, they're under JavaScript libraries or binary code libraries. And here I have two listings that show how both of these libraries can be invoked from application code in Android. Here the JavaScript code is an example of CoinHive, so that the most popular mining service that was used to mine mostly Monero. So how did we collect our data set? Well, we started by reading security reports that mentioned hashes of cryptojacking applications, and we found some of these applications identified by their hashes, and we also found some third-party miners that declare that they are miners on application markets. And we performed many interactions of the following three steps. So we defined Yara rules to match patterns in apps using the CODAS facility. The CODAS provides a matching mechanism, so when it matched a large sample of new apps using our Yara rules, we downloaded these potential mining apps. We manually analyzed all these apps to find evidence of mining or discard false positives, for instance, wallet applications and crypto exchanges applications. And we then updated the search strings, used so our Yara rules with the new patterns that we discovered during the manual analysis. Our complete Yara rules dataset is available on CODAS, and here I just want to quickly summarize to you what our dataset looks like. So in total we have 762 APKs. Most of these are JavaScript miners, so applications that use JavaScript libraries to mine cryptocurrencies. And as you can see, most of them are illicit miners, so this means that they do not declare their activities to the users. These are cryptojacking applications. We also have some binary miners, and of those almost 40% are binary illicit miners. And we have also collected miner-related applications, or we also call them scam miners. So these are apps that only declare to the user that they mine, but they actually do not mine. So their monetization is based on showing ads to the user, and they only pretend to be mining. And we report on the libraries used in these applications in our dataset. So as you can see, most of apps in our dataset, they use CoinHive SDK, which is a JavaScript to Java wrapper for convenience. And also we have a CoinHive API library that is a pure JavaScript. We have 4 binary libraries used in apps from our sample, including Minerd, XMRig, and others, and then 2 other less well-known JavaScript libraries, OTedMine API and Convong. For 57 apps, we were not able to establish which library exactly was used, mostly because they were obfuscated in one way or another. Just to describe to you our approach for dynamic detection, so we profiled 100 mining applications and 100 popular benign applications from Google Play using the Snapdragon profiler from Qualcomm. We collected various dynamic parameter values related to CPU, utilization, memory, temperature, and battery, and we computed their statistics like mean, median, max, mean, and so on. And then we performed out of these 150 features, feature importance analysis. We selected 67 features that were most important for discriminating miners from benign applications. We trained the random forest classifier with these 67 features, and we have achieved accuracy 95% with the AUX score 0.1988. And the best discriminating features from our feature set are maximum CPU utilization percent and mean battery power. So you can see from this graph that I have here that our profiler, when we were profiling the application, it was connected to the computer, so the device was charging. And with the benign applications, when they were running, the phone was mostly charging, so the battery charge was going up, while for miners, even though the device was connected to charger, the battery was mostly draining. So this means this shows how well we can discriminate mining activity from other types of activities like games or other applications by looking at such profiler based features. So I think it shows that profiling features and this machine learning based approach can be indeed a possible solution to discriminate mining from non-mining apps on device. So we have many interesting results in our paper, and please do check it out. So for instance, we have results about analysis of our dataset with VirusTotal scanners that helped us to establish the age of our applications. And also we report on some interesting characteristics of the mining applications like permissions and subscribed system events. But here I wanted to use this opportunity to briefly describe to you the current state of affairs with respect to cryptomining on Android. So our dataset was mostly collected in 2018, and of course in the end of 2017 the cryptocurrency market crashed and prices of cryptocurrencies have dropped since then very significantly. Due to this price drop, mining services have been closing. For instance, CoinHive has been closed down in March, I think, 2019. So with my student at Leiden University, Louise van der Peet, we recently looked at the current state of affairs with respect to crypto mining on Android, and we found that more crypto mining services have stopped working. So for instance, in spring 2020, GSC Coin, Coinimp, Coinable, and Moonify, they have stopped. So they were services like CoinHive, basically. And if we're talking about Monero, which is the cryptocurrency mostly mined in our dataset, well, current profitability of mobile mining is approximately 30 times less than what it was at the height of Monero price in 2018. Today, from the perspective of an attacker, showing a single ad to the user will be more profitable than a whole day of mining on this infected smartphone. So this tells us that, well, maybe it is today not very interesting for the attackers to deploy cryptojacking on Android apps. But also we can notice that the prices of cryptocurrencies go up, and Bitcoin has been on the rise recently. So once probably they reach some more interesting values for the attackers, we can expect that cryptojacking will return in its various forms, and maybe also in the form of Android applications. thank you very much for your attention. I will be very glad to answer your questions now, or please drop me an email, and please do contact us if you're interested in our dataset. Thank you.